Hello, welcome to this new video. Today we're going to solve this case which is called the Grand Prix Elimination Race. That was the case of the recent ESPN battle hosted live among 8 great players in an elimination format that basically um, saw a player being eliminated every 5 minutes, the player with the lowest score, and then resulting in 3 players battling for the title, which was actually won by Andrew Nye. So let's try to do this in a 30-minute allocation. That will be quite ambitious. I think I will have an hard stop at some point, so I probably will not be able to solve it entirely, but let's try to do our best. So we're playing this new board game called Elimination Race. Very simple. Before the game, player each selects one of the 4 cars, red, green, blue, black, and places them on the cell 0 of the racetrack. Player take turns to roll 2 dice and move their race cars according to the number of pips thrown. The winner of the game is the player whose race car crosses the finish line first. Okay, so 1 lap, I think. Racetrack is depicted on the racetrack tab. Optimal trajectory is 124 cells long. It is depicted on the racetrack tab. Okay, merely reaching cell 134 is not enough. The race car will have to go past to win. Okay, race cars, there are special rules applicable from level 4. Ticket prices. Okay, so what we have basically, okay, this is the racetrack with the optimal route, which is this one. Fantastic. Okay, let's try to see the first question, what is asking for. Red race car only, so no special rules applied. Assume that there are no other cars on the track. How many cells will your race car be able to travel with the 5 moves? Which is the total p-value on the dice is thrown. Okay, this is fairly simple. I'm going to create some named ranges. So dices and values, and this should be as simple as summing the x lookup of this of dices and values, and it is. Okay, so this was a pretty easy one. What is the correct Excel address for each of these cells on the game board? So basically cell 20 will be, sorry, cell 80 will be AX4. AX4, okay. Codes. Let's try to say I will start from B2 until BA28. So if basically this not is error number value of this, then I want the address of that. Uh, mm, mm, mm. Actually, no. Uh, this was kind of tricky. Uh, 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 because I'm interested in the code. Not sure this is the best approach. And I want to find the address of that. Uh, Yes. Now let's try to do like this. So if not is error or another way. So let's say that we have our user solver worksheet. It's taking me a while to think. So we have example 2, which is an X lookup. I'm not sure this is even needed for the following level, so maybe best to skip this if you get stuck, but let's try to solve it completely. Okay. Uh, then plus if this equals this, I will say address of row column relative reference, otherwise nothing. And then just going to copy this until BA28, I said. BA28. Okay. Let's see if this is working. Okay, so basically I'm taking advantage of the fact that only that particular cell will return my address, and then just going to say on the concat of all this thing I can even say that this equals this, and then I'm going to solve our usual way, so building a sequence of 100, then using this, and then saying let's do like this and apply our data table. So those should be the answers for level 2, hopefully, and actually checks out. Okay, level 3 deals with the red race car only. Each time the red car race car starts from the starting cell, assume there are no other cars on the track. What is the Excel address of the cell on which the red car is? Okay, so I needed that particular step in order to solve this. Anyway, I'm going to have example 3. Which is column G to column T. Okay, I'm going to transpose this. I'm going to convert to values. So XLOOKUP of dices against values. And I'm going to say that I want this sum of these. And then I need to go this is not G8, but this is now this. Copy everywhere. Okay, so it would be 04. Actually, seems correct. Let's update data table 31 to 50. And it's correct. So let's move to level 4. Level 4 deals with the green car only. Each time the green car race car starts from the starting, okay. Slow on turns, a special feature introduced. The green race car needs a new dice, I think, to make a sharp turn. There are only 6 sharp turns on the racetrack, 12 to 13, 35 to 36, okay. Example, the green race car is located on cell 9, and the player throws a 6 and a 5. The player selects to use the 5 dice first for the best efficiency. The car moves 3 cells on cell 12, and the remaining pips of the dice expire. Can move that fast through the turn. Then the player uses the other dice 6 and moves through cells 13 to 18. and that the player throws two dice simultaneously and will always use the dice in the most efficient order to move the race card the farthest. So there are no other cards on which cell will be located after the 10 moves. Okay. So basically, I'm going to consume all my remaining pips if I'm approaching the turn. In this case, I'm on cell, for example, 9. I throw a 5 and a 6. On cell 9. 1, 2, 3. Okay. 6, 13 to 18 with other 6 pips. 1, 2, 3, 4, 5, 6. So basically, the beginning of the turn will stop me, and I will use the other dice to move from the next one with no limitation. The problem is that those two are separated by more than other dice. Same thing is here because I have 37, 8, 9, 10, 11. Yes, same here. This is not true actually. So if, for example, I'm going into this, I will suffer a double stop. So this is a little bit tricky to manage, and this is clearly separated. So um, sharp turns is this one. I have example 4 now to manage. Okay, so I will need to keep track of the position in a cumulative way. So this will be my ending point if no specific rule is applied. Actually, seems a little bit too short because I need also Z. Okay. Okay, so 77, but we have the limitation, so it will be less than that. Okay. But I need to consider the dices probably wrapped in a pair configuration. So let's say that they also have wrap rows of 2. And so I'm basically using the dices in pairs now. We'll have this by plus this. Okay. So this and this plus this should give me anyway 77, but in a different fashion. Okay, so now what I need to say is potential distance plus if I need to check if this is beyond a certain sharp turn. And of course greater than the previous sharp turn. What if I simply say transpose sharp turns? Now, this is not the best thing, but if and well, the first is position 12, so even if I throw 2 6 with the first two dices, I will end up exactly there, so no effect, basically. So I will start from here. If and this is less than this lock the row, and this is greater than or equal to this. I'm not sure about the equal to lock the row. One otherwise 0. I will have to lock the columns as well because I want to drag right this formula. So basically, what I'm saying is that with this throw, I'm going past sharp turn 12. With this throw, I'm going past sharp turn 35, sharp turn 48, sharp turn 76. Okay. Uh, Now I need to limit by dices in order to consider the sharp turn and to do this in the most efficient way. So what I should say is that mm, 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 mm. Let's build also this prep dist. So same thing, but just more clear probably. Mm, 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 mm. So one option would be to do previous plus the first one and see where I get to. And so I will also need to say the minimum of this. And actually, the index of this first, the match of one against this thing, exact match. So here I'm saying I'm limited by 12. Okay, limited by 33. I'm limited by 44. It's actually okay. And let's say that in case of if error, I will get the potential distance, or even better, I will put a dash. So this will be option 1. Option 2 will be, sorry, option 1 first step, because I will need to do this. Uh, 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 uh. It's kind of difficult because now I need to add the other dice, but I don't know if I can add it and that's it, or add it to then consider again the threshold that, by the way, I did not pass with the first throw. For example, here the threshold is on 35. I'm starting with 32. If I throw a 1, I go to 33, and then plus 6, I go to 35, not 33 plus 6. Plus 6. So if this uh, is less than the index of this thing again, with the match of 1 against this exit match. So if I'm before this, I will need to say this plus the other dice, and again the minimum of this against this ugly thing. Otherwise, I can do this plus the second dice, and that's it. Okay, and the usual if error with our dash. So basically here I'm position 10, I'm throwing a 4, I stuck at 12, and then I throw another 4, 13, 14, 15, 16, as seems right. Here I throw a 32 plus 1, 33, and I basically burn everything to be at 35. Here on 39, I throw a 5, I go to 44, which is before, and then I try another, sorry, try 5, then I throw a 4, and I get stuck at 47. 70, 67 plus 5, 72, plus 5 capped at 77. Okay. Option 2 will be the same thing, actually. Previous distance, I need to lock it. J. Basically, I'm taking the second dice, should be this one, and then I will need to take the, so V14, V14 plus L14 is actually this. And L14 is actually this, I think. Let's check. So for example, here the result is the same because I have two fours. In this case, instead, I will throw 32 plus 6 will be stuck at 35, and then plus 1, 36. Here we have a 39 plus 4, we go at 43, plus plus 5, I will get stuck here, and here the same thing because I have both. So basically the final distance is, in this case, is this one, otherwise is the max of this and this. And the previous distance, if this equals dash, it will be this, otherwise this. Oh no, I went into circular reference. Let's undo the last one. Uh, 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 uh. If this equals dash, it will be this, otherwise the potential distance. this will be always this one. Okay, there's definitely a problem. 1922. 15 equals dash. Sorry, is actually the opposite. It's not equal dash. Okay, and I'm getting 74, which is actually the result of the example. So hopefully this is right. Fingers crossed. 51 to 70, usually this. Wow, checks out. 26 minutes, so not bad. Level 5 deals with the blue race car only. Each time the blue race car starts from the starting cell 0, blue car momentum effects, the player throws a total of 10, 11, 12 pips on both dice. The car will travel extra 5 cells. However, the momentum effect works until the next sharp turn is in the same move. There are only 6 sharp turns on the racetrack. Saves 12. Okay, the blue car is located in cell 0. 6 plus 5 is 11. 11 is eligible for another 5 cell. As next sharp turn is way too close, the blue race car moves only to cell 12. The other bonus moves cells expire. Or the scenario if starting, for example, from 3, same 11 pips, we'll move to cell 14 and we'll be able to use the 5 bonus move cells. So if it starts at 3, you throw an 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus 5, 1, 2, 3, 4, 5. Ah, okay, if you go beyond the sharp turn, you can use the bonus. Maybe 0 if your main move takes you to the start of a sharp turn. If the blue car is located on cell 0, player throws a 6 and a 6. Car moves 12 cells to 9, 0. The blue car is already located on cell 12. The bonus move cells expire. Okay, I think this is honestly easier compared to the previous one. Example 5. Okay, so same number of dices. I will keep the logic for okay. So this is prob dist and potential dist. Okay, so bonus. If the sum of the dice is greater than or equal to 10, 1, otherwise 0. Um, those are the sharp turns. With bonus, this plus this times 5. Then I will probably leverage this thing here. I am now almost beyond the 30 minutes allocation. So bad use of time for sure. So this is going beyond actually because I throw 6 and 6. I end Actually, the previous distance is this. Okay, so I will go at 18 plus 23. How many points do I have? Just for curiosity's sake. 700. 700 points. I would have gone to the bonus questions if this was a competition actually. Mm, 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 mm. So I can go through the sharp turn anyway without the bonus. And so I will say that if sum of these equals 0, I will take this. Otherwise, I will take the minimum of index this thing. 1 match 1 against this exit match, and this actually, let's see. So I'm at 12. Actually, I'm going beyond. Uh, but I need to use those 18 potential distance. Um, mm, 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 mm. And the max of this, actually. So 23. I should take 18 here. So the mean. No, actually this was the mean, so here I need to close the bracket. So I go to 18 here, and the previous distance is this one. So 87, nope. So basically here I get to position 6, then I throw 6 and 6, I have 12. No, because actually I can use this bonus, because I go through that and then I can use it. So my limitation should be applied only if I get the bonus, and with the bonus I will go through the turn, but if the previous stop was before the turn actually. So this should be AI, so previous distance is less than this. Okay, that's the problem. I need to move basically everything. I think it's like this. Yes, and in fact I get a 93, which seems quite okay to me. I'm not sure we have managed all the corner cases, but let's try anyway. So that was 71 to 90. Yeah, we have a few problems. For example, data set 82. I'm pretty sure this will be double turns. For example, we have 9, that's okay. Then we throw 7, we do 16. Then we throw 10, we go to 26. And with the bonus, we go to 31, which is fine. Then we throw another 8, we go to 39. Blah, blah, blah. We are at 51, we throw a 10, we go to 61, which is fine also to go to 66. Then we go to 76. And here basically we cannot use the bonus because at 76 is the beginning of the sharp turn and here the bonus needs to be cancelled. And it is actually, so I'm missing a less than or equal to here because I need to stop. $82. But what happens here? Okay, I get stuck in 76. Even if I have a double turn, 71 to 90. Okay, checks out. That was the problem. You see how silly mistake can cost you the whole competition. Let's start racing on level 6. We now have 3 race cars on the track, the red, green, and blue. The player take turns. Red starts first, followed by green and followed by blue. Both green and blue have their special effects in place. The race car all start from left from cell 0. It is possible for the race cars to be located the same cell during the race. Which car on which throw number will win the race? Okay. Um, mm, 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 mm. So we have a huge data set of dices. Mm, mm, mm. I'm afraid I will need to split this video into two because this might require some time. And what I can do is to wrap 6 of those and then split among red, green, and blue, red, green, and blue, red, green, and blue. Actually, this was the blue, this was the green, the red one is the normal. Okay, so this is the green logic. This is the blue logic. I will need to build a red logic. Let's build another worksheet. Now we have example 5. Actually, example 6. With dice is going until cell DV. Okay. I will need to wrap for 6. And here I will have basically nope. So the order is red, green, blue. So if this is green, I will need this basically. I've said red, green, blue. So this will be the last one, and red would have the first two columns. I need to extend my logic. I need to quickly build the red logic, which is, I think, this. With no, oops, with no any sort, without any sort of um, special rule. So the race is finished when I get to more than 134, actually. So finish, sorry, finish. Uh, if this is greater than 134, 1, otherwise 0. And I can just copy this probably. Okay, and then I can match 1 here, 0 exact match. And this. And throw an if error with a 999. Okay, what are the rules? Red start first, followed by green, followed by blue. Which card which throw? Use the same as a format. Win the race means getting pass, finish a turn on. So, remember that this is a guy's game. Red card is the first to move on each turn, has to move first mover advantage. The race card also crosses the same turn, race card still wins. The race card is the first mover priority over the blue. Okay. And so basically what I'm saying is what I'm saying is plus if this equals the minimum of this, this, and this, it will be green. Otherwise, red, green, and blue. So this equals the minimum of this will be green, otherwise blue. Uh, Hopefully, I know if we can have ties here. And then it will be basically the concat of this space and the minimum of this, and this. Okay, I will need 91 to 110, so I need to extend the sequence. Build again the data table. Example 6. Oh, actually, is this one? So 91 to 110. Okay, apparently like 5 seconds after I stop the video, I've got the results, which are all not correct. Um, the problem is, first of all, I need to concat without any sort of space, so that's one thing, but I don't think this will be the problem, honestly. And so this is the first one, because for example, if I go to game 91, I get red 17, while I actually got green 17. So let's see what is going on. So basically, just to recap, the order is red, green, blue. I will help me with some colors. This is the green, this is the blue, and this is the red. Okay, and we said red, green, blue, I think. Yes. So this is going there. This is taking the blue, and this is taking the red. Okay, so the references are correct. Now we have green finishing at lap 17 and red finishing at lap 17. So okay, if the order is this one, yeah, I've written 2 times green instead of putting red in the first one, which is the top priority, and that's another very silly mistake that is going to cost you a lot probably. Let's see. 91 to 110. Let me save first. Lesson learned. Okay, this will take a lot of time apparently. Mm, yeah, again stuck in the same problem. Uh, I don't remember if in the ESPN live battle this was a 30-minute allocation or more than 30 minutes. I'm curious to check what was the time allocation. Anyway, I think Andrew Knight didn't solve level 6, but probably he solved partially or completely until level 5, plus the bonuses, of course. Now I'm curious to see how easy are the bonus questions. It took me a lot actually to solve level 4, which is quite hard, and level 5 was okay-ish, I think. Level 6, all considered, if you already built a logic to manage the 3 different colors, is fairly easy. Level 7 requires to put another rule, which is the elimination car, which basically I think will affect both the removal from a car from the competition, but also the distribution again of the dices to the remaining car, which could be a tricky thing to manage. Honestly, in a 30 or even 45 minutes allocation, I think is not even approachable, to be honest. At least from my side. Okay, and it checks out. So that's the thing. Level 7 requires a small upgrade. Now the black car is added. New order it remains this. Blast, the elimination. If it lands on a cell occupied by another race car, the other race car is eliminated from the race. Uh, Elimination will change the further distribution of the dices. Okay, so that's the problem. In fact, you see that for throws 5 to basically whatever, you don't know actually what car is receiving those dices. And since I need to stop in a few minutes, I will try to solve this another time. Let's have a look at the bonus questions instead, because we have how many spectators are watching the race from the front row? They're located next to the red, white track border. Okay, this I think is fairly easy because if I just replace this with column F, which stands for front, I will have basically this. I will have this F, and also this guy here. And this, I will have, nope, I will have those plus this, and I will have also those ones, and I will have also those ones. And so if I say F countifs of of this thing locked against F, I will get 162, which is right. How many cells in total constitute the racetrack? Now that only the gray cells and the checkered start line cells count towards the racetrack cells. The red white borders are not part of the racetrack. Uh, okay. Probably safer to copy this. And I basically need to write R's everywhere. So this is basically just time consuming. No particular logic is required. And so if I say R358, yes, this is the total number of pips on all the dice is provided on level 1 to 7, excluding the examples. Um, mm, 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 mm. Let me build another one. So example 7, I think, is the most complete one in terms of dices. So BB and till column EZ. Uh, okay, X lookup of this indices in values. Otherwise 0, because many of those will basically disappear. I want to sum this, and I want another data table 120, 125 actually, excluding the examples. Let's be the data table and sum this stuff. So 2342, yes. What are the total ticket revenue from the race? See instructions for ticket pricing. We'll first do this. Consider the answer for level 4 and 5. If you multiply the smallest answer by the largest number, what is the result of your calculation? Will be mean 4 and 5, they said, of this. I don't know if it works like this. Okay, times the same thing, but this time is a max. Okay, total revenue for ticket pricing. So ticket in the green zone costs 500 front row and 200 second row. 250. Okay, just copy this. Uh, it will be 500. It will be 200, 350, and 150. So green zone first. So let's call this FG. And let's call this FG. And let's call this G, and that's it. And let's call this FO, front orange, front orange, front orange. Let's call this O, and that's it. So first green, green, first orange, and orange. Any basically a sum product of those two. 96,900. And that's correct. So, okay, I think we're there, except for level 7, of course, that I will need to tackle in a separate video. For now, thank you very much for watching, and we'll see you in the next one. Thank you. Bye.